Florida. This is NASA's launch coverage of the Imaging X-ray Polarimetry Explorer mission.
In less than 30 minutes, the SpaceX Falcon 9 rocket will launch IXPE, giving us a new set of eyes to explore outer space. Over a 2-year mission, it will use its unique X-ray vision to study some of the most mysterious and powerful objects in our universe. Thank you for joining us this morning, live from Kennedy Space Center in Florida. I'm Megan Cruz.
And I'm Marie Lewis. Liftoff is set for 1 o'clock a.m. sharp Eastern Time from just behind us at historic Launch Complex 39A. IXPE is NASA's first mission to study polarized X-rays. Simply put, it will help us understand how the universe works. The mission will focus on objects like black holes and exploded stars, honing in on their cosmic X-rays. These rays originate from places where matter is under extreme conditions, violent collisions, enormous explosions, 10 million degree temperatures, and fast rotations.
And IXPE is unique because it will pinpoint X-ray polarization. Soon after launching, IXPE will deploy its solar arrays, which will power the spacecraft. After about a week in space, IXPE will extend its boom, lengthening the spacecraft to about the size of a minivan. There that boom goes. About a month after launch, IXPE will begin its 2-year mission using 3 identical telescopes, each with a set of mirrors. Those mirrors have corresponding detectors on the opposite end of the boom. The mirrors collect X-rays from the celestial objects and focus them on the detectors, which make an image of those X-rays and measure polarization.
Polarization is a property of light, like brightness and color. X-rays are a form of high-energy light that's invisible to the human eye. By studying the polarized X-rays of these powerful objects, we can learn more about what they're made of and how they work. Today's launch is managed by NASA's Launch Services Program in cooperation with the agency's Marshall Space Flight Center, the Italian Space Agency, and Ball Aerospace.
And here are some other interesting facts about IXPE by the numbers. The bottom of the observatory, called the spacecraft bus, is nearly 4 feet in diameter. Up top is the mirror module support structure deck that's almost 5 feet in diameter. The boom is 12 feet long, bringing the fully extended observatory height to 17 feet.
IXPE's solar array wingspan is 8 feet. Put it all together, and IXPE weighs 727 pounds, roughly the same as a polar bear. It will study about 40 celestial objects during its first year in space, with more detailed follow-up observations in its second year.
And IXPE arrived at Cape Canaveral Space Force Station on November 5th for final pre-launch testing. Teams attached it to the Falcon 9 rocket last week, and now here we are, stacked and vertical on the pad, ready for launch in just about 26 minutes. Throughout this broadcast, we will show you exactly how polarization works and why measuring it will be a game changer for astrophysics.
That's right, and we will also introduce you to some of the key people who made this mission possible. NASA's Jasmine Hopkins will be interviewing those guests live, but first, let's bring in our launch commentators for today's mission. NASA's Daryl Nail and Mick Woltman sitting inside with the launch team. Daryl and Mick, how's it going?
Well, it's going great, Megan and Marie, and welcome inside the Mission Directors Center here at Hangar AE with Mick Woltman, engineer extraordinaire for Launch Services Program, going to be giving us his expertise tonight. We've had a very clean countdown so far, which is great. The launch vehicle is healthy, the spacecraft is healthy, the range is clear, and the weather is only getting better, looking fantastic. Look outside at the rocket, and you can see it is a beautiful shot, starting to fuel. Mick, just a few minutes ago, also we had a poll that kicked everything into motion.
Yeah, NASA's launch manager Tim Dunn polled the NASA engineering team, the spacecraft team, to verify they were good to start propellant loading and get ready for launch this morning, and that was great. Tim said that everything looks favorable, and we are go for propellant loading and go for launch.
And once that propellant load started, and it continues to start now, and it continues to go on as we speak, that also eliminated something that was true about an hour ago, but is no longer true, and that is we had a 90-minute window. It's no longer the case.
That's true, Daryl. Once we started propellant loading, we committed to a specific time in that window, and that is 1 a.m. this morning for IXPE's liftoff. And that's due to the fact that we're using densified or super chilled locks on board the Falcon 9 at minus 340 degrees. We need to keep it at that temperature because it warms up pretty fast. And if we can't do that, then we miss our opportunity. So we have committed to this, and we're heading for a T0 at 1 a.m.
And you can see that lock starting to fill because it's chilling the bottom part of the rocket where it is condensing and making that white cloud that you see there. This rocket has an interesting ground track in order to get this satellite into orbit. Let's take a look at that now. Once it launches here from the Cape at Kennedy Space Center, you see that red line. That's the powered flight. Then it goes into a coast over the Atlantic Ocean. Well, what's interesting is what happens next. After it passes over West Africa and it gets close to the equator, it does this. Bang! A 28-degree turn. Why is that?
Yeah, so that last burn of the second stage gives us that 28-degree plane change, which puts IXPE into an equatorial orbit, which is very important for the science mission. And Daryl, we'll talk about that later.
We're going to talk about that, as well as this historic pad right here, Launch Pad 39A, with the first ever dedicated science mission launching from here. We'll also talk about the history of that booster. But for now, back to Megan and Marie.
All right, thanks, Daryl and Mick. We want to bring in now NASA's Jasmine Hopkins, who is at a nearby viewing location.
Yeah, she's there with the director of NASA's Marshall Space Flight Center in Alabama, which is the lead center for the mission. Right, Jasmine?
That is correct, Megan. And we're going to have a great view of launch from right here at the balcony of the Operations and Support Building at Kennedy. And I am so glad to welcome Jody Singer. Thank you so much for being here.
Well, thank you so much for having me.
Absolutely.
This is a fantastic time, an exciting moment.
It is. We're very excited. And Jody, tell me, Marshall has been at the heart of the IXPE mission. How are you feeling to be here for launch?
Well, it's one of those things that, you see all the excitement, you see the sacrifices, you see how much energy our team, and it's our team, it's Marshall, but it's, the Italian Space Agency and Ball Aerospace, as well as many other folks. But our Marshall team is extremely excited about the science that we're going to get out of it, the new discoveries, and, we haven't done this before, so we'll not know what we'll find till we actually get it in operation. But it's just really exciting time and a lot of pride.
It is. And, we're very excited with you. We're all going to discover these things together. But can you tell me, what has Marshall been doing to prepare for the IXPE mission, and what will operations look like over the next few years?
Well, definitely, I'll tell you, there's been a lot of hard work, for sure. But a lot of our scientists, engineers, working with our partners, but definitely working hard. Particularly Marshall Space Flight Center is responsible for the mirrors. There's over 72 mirrors on it, and those mirrors are very critical to be able to see the light that is coming from the different objects that we'll be pointing at. And then sending it down to the detector and being able seeing we don't even know what we'll be seeing. So that's going to be fantastic, and that'll be a lot of hard work. When the IXPE is commissioned in about a month, it will, it has to go through its different stages and check out to be operational in space. But once it's there, it'll be a 2-year mission. There's going to be a lot of the things that we'll be looking at: neutron stars, understanding how planets were formed, understanding all about things that we don't even imagine yet that we're going to see, because we've never seen it before.
Exactly.
We've estimated what it would be like, but getting to see it. And then there'll be continuous research that'll be done, and it's over 12 countries and over 120 more scientists from all across the world that'll be getting this information. And that's something that's great for the United States, but it's also great for partnerships. We go together learning about our universe and understanding our world.
We go together. I love that statement. And, the Marshall team has been working behind the scenes on this to uncover the mysteries of the universe. So what do you want the world to know about your team at Marshall?
Well, I think they're pretty special.
Yeah.
It's a great team of scientists and engineers working hard, dedicated, and, really just giving it their all and really excited about the unknown possibilities, understanding our world. In addition to that, Marshall Space Flight Center, lifting off from the surface of the Earth, traveling to and through, living and understanding in our world, and now, the unknown mysteries of our universe. So, it's just going to be a lot of fun. It's so bright, the future.
Yeah.
And, and it's not just about us. It's about the next generation, understanding our world and where we're going. So the future is so bright.
Yes, it is. Jody, thank you so much for being here. And now we're going to get a forecast from our launch weather officer, Will Ulrich of the Space Launch Delta 45. Over to you, Will.
Thanks, Jasmine. Conditions look excellent for an early morning launch this morning, despite the fact that we have some clouds moving overhead the state. And that's thanks in part to a weak cool front that we're slowly seeing sag south over the area. A live look at satellite imagery shows those clouds moving from the eastern Gulf of Mexico and into the western Atlantic Ocean. Now, my colleagues at the 45th Weather Squadron are actively evaluating 9 lightning launch commit criteria to ensure those clouds pose no threat of both natural and rocket-triggered lightning. And the good news is that since we started evaluating the weather at L-2 hours, conditions look very favorable. Now, Mike McAleen, the launch weather officer for this mission, just gave his final weather brief at L-1 hours and gave a greater than 90% go for weather. And the good news is that should we need to utilize tomorrow's backup window, weather conditions remain the same with an 80% go for weather. Marie and Megan, back to you.
All right, thank you, Will. Great to hear. Fantastic news about the weather. It is currently T-minus 18 minutes from liftoff.
Yeah, previous NASA missions have studied cosmic X-rays before, but never the way that IXPE will. It's a new set of eyes in space that could unlock secrets of our universe.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos.
On your screen is a live view of the Falcon 9 at historic Launch Complex 39A, awaiting its 1 a.m. Eastern Time launch from Kennedy Space Center in Florida. Good evening and welcome to our launch coverage for IXPE, or the Imaging X-ray Polarimetry Explorer for our customer NASA. My name is Shiva Bharadwaj, and I'm a space operations engineer, and I'm joining you from SpaceX headquarters in Hawthorne, California. The Imaging X-ray Polarimetry Explorer is NASA's first mission dedicated to measuring the polarization of X-rays from a variety of cosmic sources, objects like black holes and neutron stars. We'll have a little more on the science IXPE will conduct a bit later on in the webcast, but for now, let's take a closer look at the rocket on your screen. This is Falcon 9, our 2-stage liquid-fueled launch vehicle. It's standing vertical at Launch Complex 39A. Now, the booster supporting today's mission is flying for the 5th time, and this also marks SpaceX's second flight-proven launch vehicle for NASA's Launch Services Program, or LSP. Now, this booster first flew in November of last year. It since has carried 3 Dragons and 8 astronauts to the International Space Station on the Crew 1, Crew 2, and CRS-23 missions. It also flew the Sirius XM-8 satellite to orbit earlier on this year. Now, if you're new to our webcast or unfamiliar with the Falcon 9, that bottom 2/3 of the vehicle is what we refer to as the first stage. It's covered by some white clouds around it, but it's also covered in some soot from its previous flights that you might catch in between. Now, the first stage's primary role is to accelerate all the way to the edge of space with the help of 9 Merlin engines that it has at its base. There, it'll drop off the second stage and the payload. Then, the first stage will make its way back to planet Earth, where we'll attempt to recover it on our autonomous drone ship named Just Read the Instructions. Now, if you turn your attention back to that section above the first stage and above that black carbon fiber interstage, you'll see Falcon 9's second stage. About 2.5 minutes into the flight, the stages will separate. The second stage will ignite its single Merlin vacuum engine and carry itself and the IXPE payload into a circular orbit. Now, if the launch wasn't cool enough, IXPE also marks the first Falcon 9 launch into an equatorial orbit. That means that the satellite will fly into an orbit that goes along the equator, which we refer to as having an inclination of about 0 degrees. Getting to an equatorial orbit from Florida requires a lot of rocket performance and propellant, so we won't be able to land the first stage back on land. Instead, we'll attempt to land the first stage on our drone ship stationed off the coast of Florida, while the second stage completes its orbital insertion burn. Now, the second stage will perform a second burn about 20 minutes later to get to that final circular equatorial orbit, followed shortly after by satellite deployment around T+33 minutes. Today's mission also marks the smallest dedicated payload that a Falcon 9 rocket has ever launched by a pretty large margin, making for a very roomy payload fairing at liftoff. Now, speaking of which, the fairing is that nose cone structure at the very top of the vehicle above the second stage. The fairing protects the IXPE satellite from aerodynamic heating, loads, and contamination during the ascent portion of the mission. Now, it's made of 2 fairing halves. Both of those are brand new today, and we're planning to recover them on our recovery ship named Bob, which is stationed out in the Atlantic Ocean. Now, we're coming up on about T-12.5 minutes to liftoff. The launch vehicle and satellite teams are continuing towards an on-time liftoff scheduled for 1 a.m. Eastern Time. Falcon 9 team began their final checks at about T-2 hours. Most recently, we completed the ground team poll to proceed with propellant load and launch that happened at T-38 minutes. We began loading propellants at the T-35 minute mark. Falcon 9 is a bipropellant vehicle. That means we have 2 propellants on board, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene that we call RP1, or Rocket Propellant 1. And to burn that fuel, we need an oxidizer. On Earth, most combustion or burning uses oxygen from the atmosphere as its oxidizer, and that oxygen makes up about 21% of the air that you and I breathe. However, in space, we don't have an atmosphere to provide that oxygen or other oxygen-bearing molecules, so rockets need to carry their own. On Falcon 9, the oxidizer is super-chilled liquid oxygen, what we call densified LOX, and we chill it well below its boiling point, which increases its density and allows us to load more onto the first and second stage LOX tanks. Now, currently, we are fully loaded on fuel on the second stage. Fuel loading is underway on the first stage. That'll continue about until T-6 minutes, when it will complete, and liquid oxygen loading is loading on plumes that you see around the vehicle. Now, once fully fueled, Falcon 9's first and second stage combine to carry over 1.1 million pounds of propellant, and we'll burn through most of that in the about 8.5 minutes that it takes to land the first stage and to get that second stage into its initial orbit. We'll also need an igniter to burn that fuel and oxidizer, and for that we use a chemical called TTEB. That stands for triethyl aluminum and triethyl borane. When it combines, it produces a characteristic green flash that we can sometimes see at the base of the vehicle, and that ignites our Merlin engines. Then those Merlin engines, the 9 at the bottom of the first stage, will begin throwing out their combustion exhaust out of nozzles at the bottom of the rocket, and that pushes the vehicle in the opposite direction. It's a great example of Newton's third law of motion. For every action, there's an equal and opposite reaction. A quick update on the weather. We started the day with a 10% probability of violating launch weather requirements. That is to say that we have a 90% chance of go. Been listening to the loops, and we aren't tracking any significant issues that would expect us to hold towards today's launch at 1 a.m. Eastern Time. The weather conditions also look good for booster landing on our drone ship and for fairing recovery out in the Atlantic. So with that, the launch vehicle, satellite, weather, and the range are looking good to go for that 1 a.m. Eastern Time liftoff from Launch Complex 39A. Now, as I mentioned earlier, today's IXPE mission is for our customer NASA, and it's the first NASA Launch Services Program mission being launched from Launch Pad 39A. But it also marks SpaceX's fifth as part of the NASA Launch Services Program missions. Those science missions include the Double Asteroid Redirect Test mission that we launched a few weeks ago, the Sentinel-6 Michael Freilich mission in 2020, the Transiting Exoplanet Survey Satellite launched in 2018, and Jason-3, which launched in 2016. But our payload tonight is a collaboration between NASA's Marshall Space Flight Center, the Italian Space Agency, and Ball Aerospace. The Imaging X-ray Polarimetry Explorer will help us understand fundamental physics of some of the most energetic cosmic objects in the universe by studying the special properties of the X-rays that they emit. NASA's Tiffany Russell Lockett will give us a closer look at the main components of IXPE, where those X-rays come from, and how studying their polarization will help us better understand the universe in the years to come.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the two types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water. Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus X-rays. Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPE's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction, energy, and most importantly, polarization. Over the 2 years of its prime mission, IXPE will observe more than 50 brilliant objects, like the leftovers of huge stars that exploded into supernovae, the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once were. These observations will help scientists tackle long-standing puzzles, like testing competing theories about pulsars and the details of how Einstein's theory of general relativity works. New insights from IXPE will help us paint a fuller picture of the universe, confirming or confounding our thinking in the years to come.
Now we're just over T-minus 4 minutes away from liftoff of the Falcon 9 carrying the IXPE satellite. You can see the strong back arms, the clamp arms that are around the second stage are starting to open. Those are attached to a structure, that truss structure called the transporter erector, or the TE. And in preparation for launch, we'll open up those clamp arms. The transporter erector will slowly retract away from the stage. As we get closer to T-minus 0, ground hydraulic systems will further pull the TE away, clearing the way for Falcon 9 as it proceeds into its liftoff. We refer to the transporter erector sometimes as the strongback, and you heard that call out on the loops. Now, the transporter erector is used to roll Falcon 9 out to the launch pad and raises it into the vertical launch position. It also routes power, fluid, and communications to both the rocket and the satellite. We just heard a call out there for some of those fluids that completed loading on the first stage. We've completed loading all propellants on Falcon 9's first stage. Now, the first stage is connected to the base of that transporter erector by a hinge structure, and again, that'll retract further away from the vehicle in preparation for launch. The white gas that you're seeing around the vehicle is just from that chilled liquid oxygen and some periodic venting around the vehicle. When it comes into contact with the moist Florida air, it causes water vapor to condense and forms literal clouds around the vehicle. Now, at this point in the countdown, we're about 20 seconds away from completing propellant load on the second stage. And once that's complete, the propellant loading will be complete on both the first and second stage.
Stage 2, LOX load is complete.
So with that call out, we've completed loading propellants onto Falcon 9. Coming up next, we'll see some venting from the transporter erector. We'll clear out the liquid oxygen from the propellant feeder lines, and you'll see that as some white venting around the vehicle. And then the next activity after will happen around T-minus 60 seconds when Falcon 9 transitions to internal control via its autonomous flight computers.
Gas closeouts have started.
Now, once Falcon 9 has taken over the launch countdown, it'll continue to have control of Falcon 9 through the rest of the mission. The launch director will give their final go for launch if all conditions continue to look good. And then at about T-minus 2 seconds, we'll ignite those 9 Merlin 1D engines for liftoff.
Falcon is in startup.
So with that, the IXPE satellite continues to look healthy. Falcon 9 team is tracking no issues. Falcon 9 is in startup.
LD go for XP launch.
So the launch director has given their final go for launch. So with that, we're proceeding into the last 30 seconds of the terminal count.
T-minus 30 seconds.
Let's listen in as Falcon 9 takes IXPE into orbit.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Lift Liftoff. Go Falcon. Good hunting. IXPE.
Vehicle is pitching downrange.
Nominal first stage chamber pressures.
Plus 40 seconds into flight, successful liftoff of the Falcon 9 from Launch Complex 39A at the Kennedy Space Center. We're carrying the IXPE satellite into an equatorial orbit, and we just throttled down the 9 Merlin 1D engines in preparation for the next event. That's the point of max Q, or maximum aerodynamic pressure. That coming up in about 10 seconds.
Vehicle is supersonic. Max Q.
So with that, we are through the highest stresses on the vehicle from the combination of our increasing velocity and the decreasing atmospheric density. Coming up next, the next event in about a minute will be MECO, that's main engine cutoff. We'll shut down those 9 Merlin 1D engines in preparation for the next event, stage separation. The first and second stages will separate, and then at about T plus 2 minutes, 44 seconds, we'll have SES1, or second engine start number 1. That's where the Merlin vacuum engine on the second stage will ignite to carry the second stage and the IXPE payload into orbit. So again, those 3 events coming up in succession: MECO, main engine cutoff, followed by stage separation, and then SES1. And this view, looking down on the Merlin 1D engines from the first stage, you can see the plume expanding as the atmospheric density drops off, so we get higher and higher in our atmosphere.
First stage engine cutoff.
Stage separation confirmed.
And back ignition.
So those 3 events successful: main engine cutoff, stage separation. Left-hand side of your screen, you can see a view of the first stage deploying its grid fins, starting its recovery sequence. The second stage on the right-hand side of your screen, we've got a shot of the Merlin vacuum engine glowing as it continues its ignition to carry IXPE into orbit. Next major event coming up will be fairing deployment. At this point, the second stage...
Stage 2 on nominal trajectory.
The second stage is getting to a part of the atmosphere with very low density, so we don't need to carry those fairing halves anymore. We can jettison them back to planet Earth and then attempt to recover them. Again, both of them being new fairing halves flying for this mission.
Fairing separation confirmed.
And there's confirmation of the fairing deploy, the IXPE satellite now getting directly exposed to the vacuum of space. And those fairing halves, again, will be attempting to recover those with our recovery vessel named Bob, which is out in the Atlantic Ocean. So if you're just joining us, welcome. We're about T plus 4 minutes and 20 seconds into today's mission.
Acquisition of signal, Bermuda.
On your screen is a view of the Merlin vacuum engine on the second stage. It's completing its first of 2 planned burns to take the IXPE satellite into an initial parking orbit. We had an on-time liftoff at 1 a.m. Eastern Time. The first stage that carried the second stage this far separated and is on its way back to planet Earth. Its next major activity will happen at about T plus 6 minutes and 20 seconds, and that'll be for the entry burn. where it'll ignite a few of its engines to slow down in preparation for entering the Earth's atmosphere. Now, during the entry burn, we'll relight 3 of the Merlin 1D engines on the first stage. That'll start with the center engine, followed shortly after by 2 of the side engines. That'll slow down the vehicle as we pass back into Earth's atmosphere. And we need to slow down on the first stage to reduce the entry forces, which helps us recover and reuse that first stage. Reusability is a key part
Stage 2 on nominal trajectory
of lowering the cost of spaceflight, which enables more investment into the critical scientific hardware and research. Now, Falcon 9's first stage that supported today's mission will perform this entry burn for the 5th time, having previously done so for the Crew 1, Crew 2, Sirius XM-8, and Sirius 23 missions. And those brand new fairing halves will also re-enter Earth's atmosphere for the first time. The second stage, continuing to burn, its burn will continue until about T+8 minutes. And we've heard periodic callouts that we are seeing nominal performance and following a nominal trajectory.
Stage 1 FTS is saved.
On the second stage.
Stage 1 entry burn startup.
So left-hand side of your screen, you can see the grid fins and you can see the plume from the entry burn. At this point, we are firing 3 of the Merlin 1D engines. And we're decelerating the first stage, but we're still going pretty fast. So as we're flying into the Earth's atmosphere, that soot is actually getting kicked back, the plume is getting kicked back.
Stage 1 entry burn shut down.
Onto the first stage. And the plume is carbon-based, so that'll deposit a nice layer of soot on the first stage's surface.
Stage 2 on nominal trajectory.
Nominal shutdown of the entry burn. The next activity for the first stage will be the landing burn. That'll happen at about T+8 minutes and 10 seconds. Second stage continuing to look nominal. Now, the engines on both the first and second stage are different. The Merlin engines on the first stage are optimized for sea level thrust, but the Merlin vacuum engine that you see on your screen is optimized for vacuum. And the difference there is how much we can expand the pressurized gases that are being produced by the Merlin engine.
Stage 1 transonic.
Call out there for stage 1 being transonic, so it's transitioning from supersonic speeds back to subsonic speed. And next events coming up will be second engine cutoff number 1, that's shutdown of this Merlin vacuum engine. And pretty close after, we'll hear a call out for landing burn startup on the first stage.
Stage 1 landing burn.
And back engine cutoff.
So shutdown of the Merlin vacuum engine. We've got landing burn startup on the first stage. Left-hand side of your screen is a shot from the drone ship.
Nominal stage 1 landing leg deploy.
And correction, that's a shot from the first stage. And on the right-hand side is a shot from the drone ship. We've deployed the landing legs, hopefully for a soft touchdown on just read the instructions.
Stage 1 landing confirmed.
And that is a 97th successful recovery of a first stage on our drone ship named Just Read the Instructions. This particular first stage having scored 5 flights under its belt. Now the mission isn't over just yet. The second stage on your screen is now embarking on its first coast phase, and it's in its nominal orbit. So after this coast phase, we'll light the Merlin vacuum engine for a second time around T+29 minutes to put it into the final circular orbit for payload deployment. We'll see you back here in about 20 minutes, but in the meantime, enjoy the space jams and the views of the stages.
Acquisition of signal, Cabela.
Welcome back to our webcast of the Falcon 9 mission carrying the Imaging X-ray Polarimetry Explorer, or IXPE satellite for our customer NASA. We've had a great mission so far. The Falcon 9 launched on time at 1 a.m. Eastern Time from Kennedy Space Center. We successfully recovered the first stage, and the second stage completed its first burn, taking the IXPE satellite into its initial parking orbit. Now we're just about 10 or so seconds away from a second ignition of the Merlin vacuum engine. That'll carry the second stage and the IXPE satellite into the final payload deployment orbit. So that second burn, called second engine start number 2, coming up shortly.
MVAC startup.
So there's ignition of the second stage engine. This burn was expected to last about 40 seconds. Now the initial orbit that the the second stage went into put it at about a 28-degree inclination with a high apogee and a fairly low perigee. This burn is taking us down to 0 inclination. That means we'll be flying over the equator, and it'll put us into a circular 600 by 600 kilometer orbit. And you're looking at live views of the Merlin vacuum engine and some photobombs from planet Earth behind it.
Terminal guidance.
Nominal MVAC cutoff.
So with that, the second stage engine, the Merlin vacuum engine, has shut down. The launch team will be reviewing the orbital parameters.
Nominal orbit insertion.
And with that call out, we are in the expected circular orbit right above the equator, about 600 kilometers above the Earth's surface. Now, as a reminder, the IXPE satellite is still attached to Falcon 9's second stage. We've got payload deployment coming up at about T plus 33 minutes. Now, if you're just joining us, we had an on-time launch at about 1 a.m. Eastern Time, followed by successful ascent, then stage separation. We successfully recovered our first stage, and we've completed 2 second stage burns, and the booster, and actually there's a live shot of the second stage and the IXPE satellite above planet Earth, currently over Africa. Now the booster that supported the IXPE launch today,
Acquisition of signal, Melindy,
successfully landed for the 5th time on our drone ship named Just Read the Instructions that was stationed out in the Atlantic Ocean off the coast of Florida. Reusability is a key part of SpaceX's mission to increasing the access to space, and we also had brand new fairing halves on today's mission. We'll be attempting to recover both of those on a recovery vessel named Bob. That is another great shot of NASA's Imaging X-ray Polarimetry Explorer, or IXPE. This mission is the first satellite that's dedicated to measuring the polarization of X-rays coming from high-energy objects like black holes and supernova. It's the first NASA Launch Services Program mission that's ever been launched from the launch pad 39A, a historic launch pad at Cape Canaveral. And it's SpaceX's 5th as part of that program. This program helps launch spacecraft to observe planet Earth, visit other planets, and to explore our universe. Now, the IXPE satellite does mark also Falcon 9's first launch to an equatorial orbit. The satellite is currently in a 0-degree inclination orbit above our equator at about 600 kilometers above the Earth's surface. We're about a minute away from payload deployment. And once we get into payload deployment, the IXPE satellite will then get to proceed with its 2-year mission. Now, IXPE is an orbital observatory. Its job will be to study the laws of nature on astrophysical objects that we can't recreate in labs here on planet Earth. So we'll use the telescopes on IXPE to observe them in parts of our universe. Over the next month, the satellite team will conduct checkouts of the vehicle. They'll extend a boom that holds 3 telescopes on the satellite, and then they'll start observing some of those astrophysical objects. The first one will be a supernova remnant, so the remains of a stellar explosion in the Cassiopeia constellation. It's an object that's about 11,000 light years from planet Earth.
And payload separation confirmed.
So there's confirmation of payload separation. The IXPE satellite floating away from Falcon 9's second stage to begin its 2-year mission to study some of the most energetic objects in the cosmos. And with that, it's gonna end our webcast coverage for today. So we want to give a big thanks to NASA for entrusting us with today's mission, SpaceX's 5th NASA science mission to date and the 2nd in the last couple of weeks. We also want to give a big thanks to the Range and the Federal Aviation Administration for supporting today's mission. And of course, thank you for tuning in, and we'll see you again for the next launch.